trig equations. All right. This is a little mini lesson on trig equations and what to do when you can't isolate a variable or get your equation into just sine or just cosine or even just tangent. That happens sometimes. It happens quite a bit in calculus, actually, and this is something that Mr. Schaefer wanted me to do a little bit more of this year. So I made up these little 4 problems for us to try together. The first problem here is sine minus cosine equals 1. It looks really straightforward, and it would be great if these were squares. But since they're not squared, we can't use our Pythagorean identities to make this problem easier for ourselves. So what we have to do is a little bit of guess and test smart with our unit circle values. So the easiest way to get 1 is 1 minus 0. Awesome. That's one of the ways this can happen. Where can this happen? Well, sine is 1 at pi over 2, and cosine is 0 at pi over 2. And that's the key here. Remember, our variable is theta, and it has to be the same angle. So we can only have, like when we're trying to find the solutions to these, it has to be at the same place. Where is sine 1? Only at pi over 2, and cosine is 0 there. So one of our solutions is theta equals pi over 2. We think about the other places that sine is 1 at pi over 2, sine's negative 1 at 3 pi over 2, so that wouldn't work. Negative 1 and 0 would give us negative 1, so that's not going to work there. All right, let's look for another solution to this problem. None of our fractions are going to subtract to give us 1. If we squared them, they would, but none of our fractions are going to work for that. So the only other place I can think of is where cosine is 1. So where cosine is 1, sine is 0. Okay, so that combination, 0 and 1, if I just plugged in, is going to give us negative 1. But if I use cosine as negative 1, that's going to give us a positive. So where is sine 0 and cosine negative 1? I know you're thinking pi. So there is another solution. Those are the only 2 places on our unit circle where when we add sine and cosine, we're going to get 1. So you can see that this takes a little bit of guess and test. All right, our next problem. Going to get a little more complicated here. Sine minus radical 3 cosine is equal to 1. So we want 1. And I know that my quadrantals aren't going to get this done. So if we kind of want to keep track of what's not going to work, I think that's helpful. So our quadrantals are not going to work. No, 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 no. Okay. I think we can agree that introducing radical 2 over 2 to this situation is not going to work. So our pi over 4s are not going to be options here. So let's try work with our 1/2 and pi over 3s. So if I let sine be radical 3 over 2 and cosine be 1/2, let's see what happens. So, oh, that's a minus there. Sorry about that. So, and I'm going to stay in the first quadrant and then see if I need to go to a different quadrant. So if sine is radical 3 over 2, what I've just done is made radical 3 over 2 minus radical 3 over 2, which is 0. So that combination does not work. All right. So we've said that our radical 2 over 2s won't work. So our pi over 4s are not going to work. We've said we did sine as radical 3 over 2 and cosine as 1/2. and we got 0. Even if we were gonna maybe make this a negative, then this would end up addition. So radical 3 over 2 plus radical 3 over 2 would be 2 radical 3 over 2's, which is just radical 3. So that does not work either. So it doesn't look like any of our sign, like if we could change the signs, SIGNS signs here, I don't think that would really help us either. So we just got rid of pi over 3 as an option. So if I'm going to find a solution here, it's going to be a pi over 6. So at pi over 6, sine is 1/2. Kind of start over down here. I'm even going to use a different color. Fresh start. So sine is 1/2. I have this radical 3 out in front of the cosine. Cosine is radical 3 over 2. So I'm just going to go with the first quadrant value and then see if I need to change some signs somewhere. Radical 3 times radical 3 is 3. So I'm going to keep this 1/2 minus 3 over 2. Ooh. We have a common denominator, so that's awfully nice. 1 minus 3 is -2. So I just got -1. So I'm pretty sure my combination is right for my sine and cosine. I just need a negative somewhere. I basically need to get rid of this negative in the middle. So if I make my radical 3 over 2 negative, let's see what happens. So you can see that this takes kind of a lot of guess and test. But the better you know your unit circle, the easier it is. So 1/2 radical 3 times radical 3, well, negative times negative is positive. Radical 3 times radical 3 is 3. 3 plus 1 is 4. Okay, so now I got 2. Whew. So let's switch our signs up again. Let's see if we can do negative and negative. So negative 1/2 minus radical 3 over 1 times negative radical 3 over 2. I think this is going to do it. The negative 1/2 stays. Radical 3 times radical 3 is 3. Negative times negative is positive. We've got it. So we were super close when we honed in, and we did it pretty quickly. Pretty quickly we got to pi over 6, our pi over 6's as our option for the combination that would work. It just took us another minute to figure out which sign combination. And if you weren't, honestly, I wouldn't be writing out all of these if I wasn't doing these for you. I would kind of be doing this kind of thing. All right, what happens if I make this negative? What happens if I make them both negative? What happens if I make this positive? Kind of be working through it like that with one line. So our solution here, we did sine is negative and cosine is negative. And that happens at 7 pi over 6. Awesome. So the next 4 problems are super similar, and you can look at the notes, the key online. I just wanted to do a quick video for anybody who missed class in case you needed to see kind of the way to think through that process.